Welcome to physics class. And I didn't think this would be as easy for you to get just by reading, and so I'm going to try to go through this with you. This is the first part of chapter 18b, and specifically talking about a device, a very early device for detecting electric charge. And that's 18.6, which I don't have a slide for because we're going to go right to 18.7, which is the electroscope. And this is this early device. The blue thing there is a beaker, kind of looks like a beaker. The grayish part is metal, metal ball with a metal rod. There'd be some sort of insulator holding it in place. And then down at the bottom, those are two very thin metal leaves, sometimes gold, which is why I try to make them kind of goldish. We actually did this, I think, in the college class with aluminum foil, and it didn't work real well, but it kind of worked. So some of you, those of you who took that class, actually might remember playing with it. These two leaves are hanging. They are just hanging. I separated them a little bit just so you could see both of them, but these are two metal leaves that are hanging down. So what do we do with this? Well, we can test for charge. Let me give you an example here. Okay, so here we have a rod. If you'll notice, it is negatively charged across the top there, right? I don't know if I can mark it here for you guys or not. Anyway, there's negatively charged rod. And because opposite charges attract and similar charges repel, the negatively charged rod drives all the electrons down the metal rod inside the electroscope and drives them down into the metal leaves. That means that there are now more protons remaining up in the little ball than there are electrons, more electrons down in the leaves than there are protons. And so the leaves now are both negative, and because negatives repel, the two leaves repel each other, and that spreads the gold leaves, and so you know that this rod up here is charged. Now that would be assuming that originally we didn't know whether or not it was charged. This is a way we can test it. And so if you have a negative charge, you can drive the electrons down into the gold leaves, and that shows that it's charged. Now I should mention that, and I don't have a slide for this, if you remove the rod, everything goes back to normal. It doesn't have any effect. Actually, I do. There you go. There's the picture of that. And so the rod is removed. The electrons all go back to their normal places. The gold leaves drop back to hanging down. So same electroscope, but this time we're going to take a positive rod and bring it close. Now the positive rod attracts the electrons, and so it pulls the electrons up out of the gold leaves, up through the metal tube to the metal ball, and the metal ball now has an excess of electrons, and the gold leaves have an excess of protons because the protons don't move, the electrons do. Protons stay in place, the electrons move to the top, and now both gold leaves are positive because opposites repel. The two gold leaves have repelled each other and are separated. Now when you remove the rod, everything goes back to normal again. So this is a way of testing a rod for charge, but you'll notice you can't tell the difference between a positive charge and a negative charge. Both positive and negative charged rods give you the same result. The gold leaves separate. So it only tells you if there's a charge. It doesn't help you find out what kind of charge it is. Now there is a trick for doing that, but I'm not going to go into that today. Now what if we want to add charge to an electroscope? What if we want to charge the electroscope and it stay charged? Well, we can do that by bringing a negative rod up to the metal ball and touching it. Now this is important. You have to touch it to do this. And see, this negative rod has lots of extra electrons. When it touches the metal ball, those electrons will flow out of the charged rod, the blue charged rod, down through the metal brown metal rod down to the gold leaves and give the gold leaves extra electrons. Because the gold leaves are both negatively charged, they repel each other and spread out. And then when you remove the rod, it stays negatively charged, and the electrons would rearrange, would kind of spread out, but the whole thing now has extra electrons because the rod gave it some. So if you actually touch the electroscope with a charged rod, you can actually charge the electroscope, and then it will stay charged until you do something to change that. So you can both detect charge with this. You can actually add charge to it. 18.8 brings up a mechanism, something you can actually use this for. Let's imagine we have this green rod here, and we want to know if this green rod is a conductor or not. You'll notice I have the question marks and the word conductor there. We want to know if it's a conductor or not. And we have two electroscopes. The electroscope on the left is negatively charged, and the one on the right is neutral. And so we have a charged electroscope and an uncharged electroscope, and what might or might not be a conductor. And so what we're going to do is to bring that conductor down in contact with the two electroscopes. And if this is the situation, so it looks like this, now we know this is not a conductor because there are extra electrons in the left-hand electroscope, and this conductor, or non-conductor, is not conducting those electrons from one electroscope to the other, and the one on the right remains uncharged. If, on the other hand, we had this situation, we would know that it was a conductor because electrons have flowed from the left-hand electroscope into the right-hand electroscope, and now they are both charged. And you can tell that because the gold leaves are spread out. Now, just real quick clarification. Obviously, in real life, you don't see the electrons flowing around. All you're going to see is the gold leaves spreading or not spreading. We're showing you what's actually happening, that you can't visibly see. So you can use two electroscopes as a way of checking to see if something is a conductor. You can also establish charge. Now, we already talked about one way of establishing charge earlier, where we took the rod, touched it to the electroscope, and established a charge on the electroscope. Something a lot more interesting is induction, and I think this is a really cool technique. We have these are two metal spheres on a pole. These two metal spheres are in contact with each other, and we're going to bring next to them a negatively charged rod. Now, this negatively charged rod drives the electrons out of the left sphere into the right sphere. So the left sphere has extra protons because it's lost some electrons. The right sphere has gained extra electrons, and so it has more electrons. Now, if we remove the rod, both of them go back to neutral. The electrons go return to where they came from, and they're both neutral. That was boring. So instead, let's do the same thing, that middle step there, where we brought the negatively charged rod near to the two spheres. One sphere becomes positive, one sphere becomes negative. But now we're going to separate the two spheres. Notice we move the two spheres while the charged rod is still near, not touching, just near the left-hand sphere. But the left-hand sphere, remember, lost some of its electrons. They fled away from the left-hand sphere and went to the right-hand sphere. And when we separated them, they can't go home now. So when you remove the rod, you have two spheres. One sphere which is negative and one sphere which is positive. What's really cool about this is you never touched the spheres. You just influenced them with your negative rod, and you made one positive and one negative simply by what's called induction. But if you think of it, it's kind of a neat idea that you can influence something without ever touching it. So I think that's a really cool technique. Another way to charge an electroscope with induction, specifically looking at an electroscope, is what they call induction with ground. And this is a little bit sneaky in that there is something else going on here that's being touched. Now, ground is basically an infinite source of electrons, and it's also an infinite sink of electrons. Electrons can either go in or out of the ground, depending on your situation, but it's so big, like you have it plugged into the earth, for example, which is big enough that you're not going to affect the charge of the earth with what little stuff you're doing. So if you have it grounded, and the electroscope is grounded, we bring a positively charged rod close to it. Now, this positively charged rod attracts the electrons and pulls the electrons up in the electroscope. Now the gold leaves are short some electrons, so they have extra protons. So they spread and that shows that it's charged. But the other thing the positive charge rod is doing is pulling electrons out of the ground. So it's also pulling electrons up out of the ground into the electroscope. So the electroscope's electrons are all up near the top. The ground is also feeding electrons into the electroscope. Then when you remove the ground, those extra electrons are still there in the top of the electroscope. And when you remove the rod, those electrons rearrange themselves, and you have a permanently charged electroscope, and you didn't touch it with any charged object. You had it hooked to the ground, but the ground is not technically charged, and the charged rod was near it, but it wasn't actually touching it. And so again, you're able to induce a charge on the electroscope without ever touching it with a charged object. Okay, that may have been kind of a quick overview of it, but look over the book again and watch the video again if you need to. And if you have any questions, you can contact me and I'll try to answer them. But anyway, that's a little introduction to electroscopes. They're kind of fun. If we were in class, we might actually be able to make one, but we probably won't be able to do that. If you wanted to do that, you could probably Google how to make your own electroscope, and they're not really that hard to make. You need a glass and some aluminum foil, basically. So if you're interested in doing that, paperclip, feel free to do that. Anyway, well, have a good day, and good luck on your homework.